We have different presentations, so we'll start with Dr. Dimitrios Terzis, who is CEO of Medisoil and leader of the project, the BioGeos project, that will talk about principles of soil biocementation. Then Mrs. Maren Katzenbach, which is our grouting expert, will talk about applications and performance consideration. Dr. Alexandra Clara will go to the scientific part of the things by discussing the current challenges and the future directions for biocementation. And Dr. Din-Hyun Kim will summarize our current activities, the involved people and so on, and then we'll manage the Q&A session. So I will now leave the floor to Dimitrios to start with the short introduction and then to his talk.
Yes, thank you very much, and welcome from my side as well. I will start by briefly introducing you the principles of biocementation to eventually answer the question why our field really needs biocementation solutions. Then I will elaborate on what we believe is the biggest barrier towards the massive and mainstream adoption of biocementation. And this is no other than the complete supply and production chain, and especially the management of nitrous ammonium, which is a byproduct of cementation. So once it becomes clear what elements contribute to biocementation, I will further present on the economics and environmental performance of the technology, before concluding with the 2 example projects that we designed and delivered here in Switzerland, where our solutions were integrated in real scale geotech works. Now we'll leave the floor to my colleague, Mrs. Maren Katzenbach, to talk about applications considerations.
Okay, thank you, Dimitrios. I think you marked already very important fundamentals of soil biocementation and its great potential in the industry. And you also already mentioned an example of a possible application of how a possible application might look like. However, before getting there, as engineer, we first must decide which product to use. And this decision depends basically on 2 aspects. First, the global objective of the grouting works. So do we want to consolidate or waterproof or even both? And the other essential parameter is the material to be injected, which together with the grout determines what we call the penetrability. So, in short, why should we choose biogrouting? Well, apart from the fact that it is obviously environmentally friendly, there are many more advantages, as you see depicted on this slide here. I would say altogether it stands out by its minimally invasive character. And with this, I pass the floor now to Alexandra, who will give a comprehensive overview of the challenges and future directions of biocementation.
So thank you, Maren, for the introduction. So throughout this presentation today, you have been able to see the great strides that we have really made on the tech transfer of biogeotechnics. However, it really would be elusive to think that the road is paved. So this is why I would like to use this opportunity to highlight some of the challenges ahead and give you a brief overview of how our team at EPFL is really leveraging these challenges to plot a course towards future research directions. So we have made significant advances on the performance of individual biocementation treatment components. And we're working together as a team on the more integrated configurations. I hope that from today, we have been able to convince you, or at least in part, that the status quo of soil stabilization, which is highly dependent on cement and petroleum-based derivatives, does no longer make any economic or environmental sense. Biocementation can deliver a sustainable infrastructure by not only replacing cementitious systems, but also by creating infrastructure that ultimately looks after itself. So my question to you today is, how can we all, industry and academia, work together to transform the future of soil stabilization?
And thanks to the presenter for your valuable lectures. It was really good to see the overview of the many practical technical issues regarding this technology. And also it is quite impressive to see that we are trying to deliver the nature-motivated geotechnical solution to the reality. As you saw from the presentation today, we are actually applying this technology to the field, but just treatment to the field is not enough to evaluate its engineering property and performance we are putting a lot of effort in the laboratory works. We investigate the mechanical behavior by the lab scale experiment. We visualize the reaction at the micro scale to find the fundamental knowledge, and we are blending this effort with the theories and models. We ultimately want to deliver this technique to the real world with the engineering perspective. Thank you all, audience, for your huge interest in our project and this webinar. Also appreciate Professor Lalui organizing this webinar.
So with this, we are coming to the end of this webinar. Really, we hope that you enjoy it and that it responds to your expectation. At least we did our best to share with you our knowledge, and we hope to see you in one of our coming webinars. So thank you very much and all the best. Bye.
Bye.
Bye-bye.